set operations. Now there is a condition, and that condition has to be fulfilled before we can use set operations on two relations. Okay, it's a binary operator, it works on two relations. So the compatibility condition is the relations must have same arity . Just recollect what arity was. Arity was the number of columns in a table. Okay, so they should have same number of columns in the table. And the other is the domain of ith attribute of one table, or rather of relation R1, should be equal to the domain of ith attribute of R2, which basically means the first attribute of R1's domain and the second attribute of R2's domain should be equal. Similarly, the second attribute's domain and the second attribute's domain of R2 both should be same. Okay, so let's suppose we have two relations. We have R1, A1, A2, A3 and R2. Obviously the first condition was they should have same arity. So even here we have A1 dash, A2 dash and A3 dash. So as per my second condition, domain of A1 is equal to domain of A1 dash, and domain of A2 is equal to domain of A2 dash, and the domain of A3 is equal to domain of A3 dash. So if these conditions are fulfilled, I can use my set operators on these two relations. So let's look at the set operators. The first operator that we have is the union operator. Okay, let's suppose we have two tables. First table is project manager and the second table is engineer. Okay, both of these tables have employee ID, name, email. This has also employee ID, name and email. Okay, so this is my table. And this is my engineer table. As you can see, these both relations or tables are compatible. Okay, so let's fill this table with some random values. We'll have 1, 2, 3. Name is Joe. Email is Joe at something. Then we have 2, 5, 6. Name is Joanne. Email is Joanne at something. Another employee ID is 742. Name is Tim and email is Tim at something. And also in engineer we have, say, Joanne. oops, this is employee ID, right? So we'll have 256 Joanne, and it's Joanne at something. Here let's say we have 742 Tim at something, and we have Rob. Oops, I keep doing this again and again. We have 341 employee ID, the name is Rob, and his ID is Rob at something. Okay, so in this table we have these three values, and this table we have these three values. Obviously this value means that Joanne is an engineer whose email is Joanne at something, and his employee ID is 256 rather, and a row in this table means Joe is a project manager whose employee ID is 123. Okay, so now let's suppose I want to find out all the people who are either engineers or project managers. So how would I do that? Just understand from this table, if I take the union of these values, I would get all the people who are either project managers or engineers. So I would write project. Say, let's assume I don't want all the people, I want name and email of people who are either engineer or project managers. So I would do it as project name, comma, email from project manager, and I would take the union of the projection of name and email of all the people who are engineers. Okay, so we have two relations working here. There is one relation which is going to give me all the project managers, or rather name and email of all the project managers, and another relation which is going to give me name and email of all the engineers. And if I do a union of these two, I'm gonna get the name and email of all the people who are either engineer or project manager, right? This is either engineer or project manager. So what would we have in this table? We will have Joe, Joanne, Tim and Rob. Okay, so the result of this would be Joe, Joanne, Tim, Rob. Okay, Joe at something, Joanne at something, Tim at something, and Rob at something. So this is the result of above query. Just realize one thing, we do not repeat the rows. Despite the fact that Joanne is common in both the tables, we only display Joanne once in this relation, okay? Because a relation is a set of records, and in a set duplicates are not allowed, or rather it really doesn't affect a set if we have duplicates. Okay, so if we have a set as A1, A2, A1, A3, and we have another set as A1, A2, A3, then both the sets are equal. Okay, now the next operator is intersection operator. Okay, intersection operator is used to find the rows which are intersecting, which are common between two tuples. Intersection operator is represented as this inverted U. Okay, inverted union. You can think it in this manner. So let's change our query from name and email of persons who are either engineer or manager to name and email of persons who are both engineer and project managers. Okay, so how would we write the query? We would say project name and email from engineer, project name and email from project manager, and take an intersection. So we will take intersection between these two relations, R1 and R2. So what would we get as a result? We have Joanne, which is common in both the relations, right? Joanne, and we have, do we have someone else? Do we have Joe here? No. Do we have Tim? Yeah, we have Tim here. Okay, and the next guy is Tim. So the result of this operation would be, I would have Joanne at something, Tim at something. So this is my resultant relation. Okay, this is the result of this query. The next operator that we have is a set difference operator. Set difference operator